All right, so continuing on, we want to look at some of our other methods. So on our next problem, we have x squared equals 64. So we have two different ways that we can do this. I'm going to show you the first way, which is probably the way that I would prefer, and then I'll show you the other way, which is not that it's a bad way, it's just that a lot of students will run into issues when we start trying to use this second method. But we'll look at it in this one now. So notice that on my x squared equals 64, right now we don't have a quadratic equation because it's not set equal to 0. So we need to move our 64 over, and we would move it over using subtraction. Now notice on this one, my x squared doesn't have a number that has a common factor with 64. And my 64 doesn't have an x to have a common factor with x squared. So we can't factor out a greatest common factor. So we need another method. And the method that we have is called the difference of squares. So hopefully we notice that both x squared and 64 are perfect squares. And that obviously we have subtraction, which is another word for difference. So when I have two things that look like that, we actually have a formula that we're allowed to use that breaks it apart into those two separate factors for us. So basically what happens is we take the square root of each of them. Whatever we get, we're going to subtract them, and then we're going to add them. And that's going to give us our two factors that we need to use. So in this case, I have an x squared and a 64. Well, the square root of x squared is just x, and the square root of 64 is 8. So I need to subtract those two and then add those two. Now, once we have it separated into two separate fractions, we can set each of those equal to 0 separately. And then we have nice, easy linear equations that we should be able to solve. So we get that x equals -8 and +8. All right, so let's go on. So in our next example, I have x squared plus 9x plus 20 equals 0. So first off, notice that my x squared and my 9x share a factor of x, but my 9x and my 20 don't share anything, and my 20 doesn't have an x either. So we can't factor out a greatest common factor. Also, this time we have a trinomial, which means that we're not going to be able to use our difference of squares method either. So we need one more method. And then this is the last method for our factoring that we'll have for right now. And I like to call this the AC method. Other people call it other things. I've seen it called the magic method, the break apart method, or factoring by grouping. Now, you don't have to use this method. There are other methods out there. There's one that's called like a square method. You can kind of just do a guess and check method. However, just know that this is going to be the method that I prefer and the one that I use when I work examples in class. However, as long as you're using correct mathematical steps whenever you're factoring, I don't care necessarily which method that you use. So the way that this is going to work, remember that our equations are written as ax squared plus bx plus c. And they're going to equal 0. So right now I have a quadratic and I have an x squared. And we can't do anything to that x squared to try and solve until we get it broken apart. Also, we can't factor out a greatest common factor because they don't all share a common factor. So what we want to try and do is break apart our middle term, that bx, to be where we have 4 terms. Because then once we have 4 terms, we can create 2 groups and factor out a greatest common factor from our 2 different groups. So the way that we do that is we're going to take our a times our c, and it's going to give us some number. And then what we want to do is we want to find 2 numbers that when I multiply them together, we get a times c. However, we also need to have those same 2 numbers give us b when we add them together. And it doesn't matter what these 2 numbers are, so let's just for notation's sake, let's say this is star and heart. So star and heart have to add and also multiply to give us the correct terms. Once we find find those, what we're going to do is we're going to use those two terms to break apart our middle term, and then we're going to factor by grouping, which we'll look at how to do that in just 1 second. So now let's look at an example with some numbers like we have over here. So I have an x squared plus 9x plus 20. So for my example, my a equals 1, my b equals 9, and my c equals 20. So this tells us that a times c is going to be 1 times 20, which is 20. So I'm looking for two numbers that multiply together to give me 20, but they also have to add together to give me 9, and they have to be the same two numbers. So I'm just going to go through my factors of 20. Well, my first factor is always 1 and 20. Well, 1 and 20 don't add to give me 9. My next factor is going to be 2, so 2 and 10. Well, 2 times 10 is 20, but 2 plus 10 is not 9. 3 is not a factor of 20, so my next factor is 4. Well, if I notice, 4 times 5 gives me 20, and 4 plus 5 gives me 9. Now, the better that we get at these and the more that we do them, you'll be able to just kind of see those numbers that work much faster. But until you get there, just go ahead and, like I did, work through all of the factors of your number that we get by multiplying a times c and figure out which two work. Now, like I said before, we're going to take those two numbers and we're going to break apart our middle term. So I'm going to write 4x plus 5x, and I'm going to substitute that in for my 9. Notice that I'm not changing the value of my equation. I'm just changing how we're writing it. So as long as my new equation still equals my old equation, when I simplify it, I'm allowed to rewrite it however I want. And so like I said, what we're going to do is we're going to break this apart into two separate groups. So this is why sometimes it's called factoring by grouping. Because now, notice that in my first group, I have a common factor now. And in my second group, I have a common factor now. So we're going to factor out a greatest common factor for our two groups individually. So notice that my x squared plus 4x have an x in common. And if we factor that out, we'd be left with x plus 4. And then my second group has a 5 in common. So we would be left with x plus 4 as well. So we should, as long as we did all of our steps correctly, notice that now this stuff in parentheses that I'm left over with is the same thing, which is important to note. And then we also need to note what we had to pull out, because those are going to end up being my two factors. So I'm going to factor out or pull out the x plus 4. So I'm going to have an x plus 4 by itself. Then my other factor is going to be whatever we had left over, or whatever we had to pull out, which was our x plus 5. So then we can set each of our factors now equal to 0, and we get our nice, easy linear equations that we should know how to solve. So we get x equals -4 and x equals -5. So we get two solutions. Now, a lot of students usually ask me at this point, okay, well, I found my two numbers. They happen to be 4 and 5. Well, when I factored it, I also got 4 and 5. Does that always work? And the answer is kind of. So if my a value is 1, then yes, it'll work. Whatever two numbers we get right here are just going to be the two numbers for my factors. However, if my a value is not 1, like in our next example that we're going to look at, that's not necessarily going to be the case. So we do need to be a little bit careful with that. So we're going to use that same method that we've been working with, our AC method. However, notice this time our A is equal to 6, our B is equal to -23, and our C is equal to 20. So this time, when we multiply A times C, we're going to get a little bit of a bigger number, but that's okay. So we do A times C is 6 times 20. Well, 6 times 2 is 12, and then I add my 0. So I'm looking for two numbers that multiply together to give me 120, but they also have to add together to give me a negative 23. And the big thing here is going to be to realize that because we have a negative, one of my numbers is probably going to be positive, and one of my numbers is probably going to be negative. So we just want to work through our options. So I could do 1 in 120, but that's probably not going to work. So I'm probably going to go up a little bit higher to see what other options I have. So notice if we use 2, we would have 2 and 60, so that's not going to work. If we had 3, we would have 3 and 40, so that's also not going to work. We had 4, we would have 4 and 30, so we're getting closer, but still not quite. If we had 5, we would have 5 and 24. 6 would be 6 and 20. And then skip 7, and then we have 8 and 15. Well, 8 plus 15 is 23. Now, our 8 and 15 are both positive, but I need to end up with a negative. And so, like I said, my negative indicates to me that at least one of my numbers can have to be negative. However, both of them can be negative because if I have a negative 8 and a negative 15, we'll notice that a negative times a negative gives me a positive. And then those two numbers will also still add together to give me the negative 23. So now, like I said, we're going to use those two numbers to break apart our middle term. So we have a negative 8y and a negative 15y. A common question that I get asked is, does it matter which order I put those in? Like, could I write 6y, sorry, that should be squared, minus 15y minus 8y plus 20? And it doesn't matter. As long as you found your two numbers correctly, it doesn't matter which order you put them in. You'll get the same thing in the long run. So we do want to factor by grouping now. So notice that our 6y squared and our negative 8y have a 2y in common. So I'm left with 3y minus 4. And then notice that our next two have a 5 in common. However, remember that we need our parentheses to be the same thing as our first parentheses. So if we just factored out a 5, we would be left with a negative 3y plus 4, which isn't quite the same as this. So we actually need to factor out a negative 5 in order to flip those two signs, because now it'll work. And it's still all set equal to 0. And so now we can factor out our 3y minus 4, and we're left with a 2y minus 5. So notice in this case, my negative 8 and negative 15 are not my two factors here. So that's why it's really important that we don't just write down those two numbers when our leading coefficient is not 1. So then I'm going to set my two values equal to 0, and I'm going to get 4/3 and 5/2. We got fractions, but that's okay. Our answers don't always have to be whole numbers. Sometimes they're going to be fractions. And that's where this method's going to come in really handy versus graphing, because it would be really hard to find 4/3, because 4/3 is going to have a repeating decimal that wouldn't be easy to try and plug in on our own. But when we do it algebraically, we can find the exact solution. All right, so our last example is going to be usually my students' least favorite. However, especially since we're doing this along with physics, it's the kind that's going to come up a lot. And it's a word problem. So we're talking about a javelin. So if you haven't ever seen a javelin, it's kind of the long pointy stick that they throw in track and field. So it says the height of a javelin in feet is modeled by h of t equals negative 16t squared plus 79t plus 5, where t is the time in seconds after the javelin is thrown. how long is it in the air? So the first thing that I usually like to do with these types of problems, since we're modeling something that's a real world application, is I want to draw a picture. To me, it just makes more sense when we draw a picture. And so we're going to throw this javelin into the air, and it's going to go up. I don't know how far it's going to go up, but it's going to go up. And because we're down here on Earth, and we have this thing called gravity, we know at some point it's also going to have to come back down. And so we create a parabola-like shape, which should be fairly remind us of our parabolas that we have from our quadratic graphs. And so what we're going to do is we're looking for time. And so hopefully we remember from our other science classes that time is going to be our dependent variable. Time is going to be our independent variable, and then like height or other things are going to be our dependent variable. So for us, time is going to go across our x-axis, and height is going to go across our y-axis. So basically, we know at some point, now I drew this line over here. It's actually not going to be the case, so I'm going to draw it over just so we don't get confused. So our x-axis is probably more going to go through something like this. So we need to find two different spots at where it would touch the ground. Now, some of us might be thinking, well, why is it not starting at the ground? Well, if we think about a person throwing a javelin, the person's going to have height. They're not going to just like have the javelin on the ground. They're going to throw it from about this height of their shoulders. And so it would start at some height, which is why we're not starting at 0 for our height. But we are starting at time 0, which means that we need to figure out what this time distance is right here. And hopefully we recall that our x-intercepts and our solution to roots are going to be the same numbers. So we could solve this like we've been solving algebraically and get those x-intercepts. So since we're looking for when it's going to hit the x-axis, that's going to be where our h of t is equal to 0. Which, by setting it equal to 0, is creating an equation for us, which is helpful because we need something to be able to solve for. And now we're going to solve by factoring. So notice I have a leading coefficient that is not 1, so we're going to have to do our a times c. So we have negative 16 times 5. Which is going to seem like it's going to give us a big number, but don't freak out. So it's going to give us a negative 80. So we're looking for two things that multiply together to give us negative 80 and add together to give us a positive 79. And there are lots of factors for 80 because it's like 2 and 4 and 8 and 10 and all of those above. However, remember, we want to start from the beginning because if I notice, this is negative. So I know that one of my numbers is going to have to be negative, and one of my numbers is going to have to be positive. And it just so happens, if I do a negative 1 and a positive 80, I get that positive 79 that we're looking for. So just because we get big numbers doesn't mean it's necessarily going to be hard. So then we're going to go ahead, split apart that middle term. So this time, instead of an x, I'm going to put a t, but it's going to work the same way. Then I'm going to factor by grouping. So we're looking for what is my common factor between 16 and 80. Well, since 16 goes into 80 5 times, that negative 16 is going to be the common factor. And then they both have a t in common as well. So I'm going to go ahead and factor up the negative 16 just to make our lives a little bit easier. And when we do 80 divided by 16, it's going to give us 5, but we do need to flip that sign. Then on our second one, we're going to factor out a negative 1 so that we flip the sign as well. So lastly, factoring out that common expression of t minus 5, we're left with a negative 16t minus 1. So now that it's all nice and factored for us, we can set each of those factors equal to 0. So we're going to get t equals 5, and t equals a negative 1/16. which makes sense because we knew that we're going to have a number before my y-axis and a number after my y-axis. However, because they asked us how long it was in the air, algebraically we have two answers, but we only have one answer that's going to make sense. Mr. Bowman's talked about this a little bit. It's not going to make sense for us to have negative time, so we're going to pick the time that is positive. And I do want to label it with whatever our unit is, and so in this case, it would be 5, or it would be seconds. So we would get 5 seconds as our solution. And now this can be applied to any type of projectile motion. So whether we have a baseball or a football, if we are able to do our project, we're going to be launching marshmallows. So this type of analysis would work for any type of projectile. We just happen to be doing javelins.